Okay, so this PAL contains fixed OR array and programmable AND array. So programmable AND array means what? Here we can do any type of programming for the AND array. Same as that of the PLA, here also the AND array is programmable. So due to that, what we are going to do is we can do the modifications on the AND array. That's why we are going to uh, implement this one by using the K-maps. So after implementing this by using the K-maps, just what we are going to do is we need to consider the circuit diagram for this like this. See here what we are having, 0, 1 lines represents the I1 input, I1 bar input. Next 2 and 3 represents the I2 input, I2 bar input. So initially when you purchase the PAL, all the connections are established. And here, so based on the number of outputs which we are having, and in that how many number of product terms we are having with respect to that, you need to purchase that type of PAL. So here we are just for example sake, we are considering a fixed OR array which contains, each OR gate contains 3 AND inputs. Okay, 3 AND gates as the inputs. So for example, after simplifying the corresponding output equations by using the K-map, if any one of the Boolean equation contains 4 product terms, then what we are going to do is you need to choose another type of PAL such that which contains the number of inputs for this OR gate is 4. So like that, based on the number of product terms, that is maximum number of product terms which we are having in the output equation, with respect to that you have to choose a PAL. Now here if you are just considering, you are having one doubt that ma'am, in one equation we are having 4 product terms, and in another equation you may get the 3 equations, that is 3 product terms only. Then what we are going to do for the fourth AND gate? See here, uh, we are having contacts of I1, I1 bar, I2, I2 bar, I3, I3 bar, I4, I4 bar, like this. So due to that, what happens is I1, I1 bar both are connected to AND gate, means based on the postulates and theorems, then what we are having, uh, I1 into I1 bar. So what is the value? Which is 0. In the same way, I2 into I2 bar, which is equal to 0. So no need to do any removal of connections across the third AND gate. Then what happens is the output of this AND gate is produced the value as 0. So due to that, the first AND gate and second AND gate are working normal, and the third AND gate produces the output 0. So like that, based on our requirement, what we are going to do is you need to choose a PAL which has a programmable AND logic and fixed OR logic. And if you are going to consider here, F2, F3, F4 are not having any feedback. See, F1 is again acts like a input. Why? Because if you want, you can use this any one of the output equation also as a input equation. That is, for example, if you are taking F3, if this F3 contains some 4 product terms, in that 4 product terms, 2 product terms are exactly same as that of our F1. Then F3 you can represent that one as F1 plus some other product terms. Like that, if you are implementing, then F1 is acts like a our input also, and also it acts like a output. So we can call this F1 as a input output terminal, in out terminal. Okay, and remaining I1, I2, I3, I4 acts as a pure inputs. F2, F3, F4 acts as a pure outputs. Like this, you need to design the corresponding PAL circuit. So this is same as that of the normal implementation of the combinational circuit, but only the difference is here we are having fixed number of product terms or AND gates for the OR gate. Why? Because the OR gate contains a fixed OR array. That is, the PAL contains fixed OR array, but it contains programmable AND array. So due to that, we can do the programming only for the AND logic, and we cannot do any programming for the OR logic. So based on this, if you just consider one of the example here, so here we are going to consider implement the following Boolean functions by using PAL, and we are having 4 terms. W, X, Y, Z, and totally 4 inputs we are having, and the corresponding min terms we are having like this. Now if you want to implement this one, just I'm going to explain you the solution for this. It's very easy. So this is the Boolean functions they are giving. W is equal to sigma m of 2, 12, 13, and X is having these number of minterms Y and Z. Now 4 inputs we are having, 4 outputs W, X, Y, Z. 4 inputs, 4 outputs, and totally 16 minterms we are having. So here it is a programmable AND array. So due to that, same as that of the PAL, PLA, PAL also programmable AND array means, then what we are going to do, you have to consider as many less number of input combination as possible. That's why here what we are doing is, by using the K maps, we are considering the simplified solutions for the corresponding inputs W, X, Y, Z. So the W contains 3 minterms, 2, 12, 13. So here we are having a pair and it is a isolated cell. So due to that, W becomes A bar, B bar, C, D bar plus A, B, C bar. Like that, X contains a octet and also a pair. So A plus B, C, D. In the same way, Y is having 4 quads. So CD plus A bar, B plus B bar, D bar. And Z contains 2 pairs and 2 isolated cells. So due to that, A, B, C bar plus A, C bar, D bar plus A bar, B bar, C bar, D plus A bar, B bar, C, D bar. Now if you observe this A bar, B bar, C, D bar, this last one, and A, B, C bar, this first one, both are exactly same as that. If you add these two, directly you are getting the W term. So due to that, what we are going to do is, this A, B, C bar plus A bar, B bar, C, D bar, you can replace this with the W. So Z value is equal to W plus A, C bar, D plus A bar, B bar, C bar, D. Now this is the overall equations which we are getting in the corresponding equation. So W contains A bar, B bar, C, D bar plus A, B, C bar. Like that, X, Y, Z contains the equations. Now if you count the number of product terms in each terms, see here, if you are taking the W, how many product terms we are having? 2 product terms. In X, 2 product terms. In Y, 3. And in Z, 3. So total number of product terms, maximum number of product terms in these 4 equations contains Y and Z, which are 3, 3. So due to that, you have to choose a PAL which has a fixed R array and takes maximum 3 AND gates. So you have to choose the PAL like this. So here this W contains 3 AND gates, X contains 3 AND gates, Y contains 3 AND gates, and also Z contains another 3 AND gates. So before going to draw the PAL diagram, if you want, you can draw the PAL program table same as that of the PLA. But here the product terms for each AND gate are fixed. That's why, which are 3 3 AND gates. That's why if you are taking the first, second, third AND gates, these are all connected to W. That's why what we are having here, A bar, B bar, C, D bar, A, B, C bar, but there is no term for the third one. So you just kept it as hyphen. And how many inputs we are having here? A, B, C, D, and A, B, D are in the which form? Complemented form. That's why we are making it as 0. C is in the uncomplemented form, so it is 1, and there is no W. That's why we are keeping it as hyphen. And A, B, C bar means A, B are ones, and C bar means it is a complemented form 0, and there is no D and W. That's why hyphen. And the third AND gate is not available in W. That's why we are keeping hyphens. So W value is equal to A, B, C bar plus A bar, B bar, C, D bar. In the same way, 4, 5, 6. are used for X, where X contains A is one product term, BCD is another product term. So A is 1 and remaining all the inputs are not there, and BCD are ones and remaining A and W are not there. In the same way, we are going to write for the Y and also for Z also. So now when we are writing Y, this Y contains 7, 8, 9 product terms which are CD, A bar B plus B bar D bar. So CD are ones and remaining all are not there. So we are keeping it as hyphens. A bar B, A bar is 0, B is 1 and remaining all are hyphens. And B bar D like that. So we are going to get the Y equation. Now 10, 11, 12 AND gates are used for getting the Z. And what are the product terms we are having in Z? First one is W and second one is A C bar D and third one is A bar B bar C bar D. So W means remaining inputs are not there, only W is there, that's why it is 1. And A C bar D, that is 1, 0, 1 and B and D are hyphens. In the same way, A bar B bar C bar D means 0, 0, 0, 1 and W is not there, that's why it is hyphen. So based on these connections or these PAL program table, what we are going to do is you just draw the PLA diagram. So if you just consider this PAL diagram, here what is the first term we are having? A bar, B bar, C, D bar. So A bar, B bar, C, D bar connections you just kept as it is, and remaining connections you just remove. So due to that, first AND gate contains these terms and second AND gate contains A, B, C bar. So due to that, A, B, C bar is connected to the second AND gate. And third AND gate, actually, originally if you are considering, this third AND gate contains these cross marks like this for all the terms. So due to that, what happens? A bar into B, B bar into C, C bar into D, D bar into W, W bar. So you, based on the postulates and theorems of the Boolean equations, A into A bar always produces the output as 0. That is nothing but this AND gate we are not using. So this is a normal diagram only which are writing in our notebooks. That's why just I am, for easy sake, what I am doing is for this line I am just crossing the total AND gate. So this cross mark in the AND gate represents that we are not using that AND gate for this W. That is the meaning of crossing the AND gate across this point. That is, crossing the AND gate means that AND gate we are not using, but it is available in our PAL chip, but we are not using this AND gate for our sake. Now due to this, what happens? Here it produces the value as 0. So 0 plus any A in the corresponding OR gate is how much? A only, no? So due to that, whatever these two AND gates produces the output, it may be 1 or it may be 0. We are going to get the values exactly same. Now if you just see Z value, Z is contains the input as W. So due to that, what we are going to do is you have to use this W as a in-out input, that is which acts as a input and also which acts as a output. So after getting the W equation, you just write a feedback. So this W you just connect it to as the input equation here. After that, you just consider the W bar. So we are getting this W and W bar also. And what is the second input we are having? X. So we are having X. So X contains only two terms again here. One is A directly and second one is B, C, D. So directly we are connecting B, C, D, and here also we are not having third AND gate or third product term. That's why we are keeping the cross mark across the third AND gate. In the same way, you just draw for Y and also you just draw for Z also. So Y
మ్యామ్ ఇక్కడ
contains,
బార్ ఎందుకు
చెప్పమ్మా
మ్యామ్ ఇక్కడ బార్ ఎందుకు కనెక్ట్ చేయట్లేదు మ్యామ్? పైన కనెక్ట్ చేసినట్టు
ఎక్కడ
డబ్ల్యూ దగ్గర కనెక్ట్ చేసినట్టు డబ్ల్యూ బార్
W, this line acts as a W by giving the fuse connection here. Am I right?
Yes, ma'am.
So if you do the connection like this, then what happens? For this total wire acts as a W only, and across this point we are connecting the inverter. So for
W bar.
W, if you are connecting the inverter, means it acts like a W bar only, no?
Yes, ma'am.
Actually, in our equation, W bar is not useful, but actually the general diagrams are like this. That's why we are always considering A bar, B bar, C bar, D bar. And if you are having extra input W also, W bar also we are taking. That's all. But here we are not using that
ఇంకోటిది
one.
డి
చెప్పమ్మా.
ఈక్వేషన్ లో డబ్ల్యూ వచ్చింది కాబట్టి ఇక్కడ డబ్ల్యూ పెట్టుకున్నాం, లేకపోతే పెట్టుకునేటోళ్ళం కాదు కదా.
అవసరం లేదు. ఇట్స్ నాట్ నెసెసరీ.
అక్కడ ఇప్పుడు డబ్ల్యూ తో పాటు ఇంకో టర్మ్ ఏదైనా వచ్చినా అని సపోజ్ ఎక్స్ అని మళ్ళీ ఇంకోటి
తీసుకోవాలి నాన్న.
కన్సిడర్ చేయాలి.
Those things are also acts like a feedbacks only. ఓకే. ఫర్ ఎగ్జాంపుల్ మీకు అన్ని ఈక్వేషన్స్ లోను ఎక్కడ నీకు రిపిటేషన్ ఎక్కడ రాలేదు, దెన్ నథింగ్ యాక్ట్స్ యాజ్ ఏ ఫీడ్బ్యాక్. దట్ ఈస్ ఇన్అవుట్ లాగా ఏది యాక్ట్ అవ్వదు. డైరెక్ట్లీ యూ జస్ట్ ప్రోగ్రామ్ దీస్ AND gates and directly you just write WXYZ like this. Then what happens? These are all acts as a inputs, these are all acts as a outputs. There is no particular input output equation in PAL. But inbuilt PAL contains one of the term or one or two terms which takes this input and also output. That's why that feasibility is there in PAL. So due to that we are taking like that. Okay. So if you are not having this type of connection, then what happens? This jet contains totally 4 number of product terms. So 4 product terms means you have to choose another type of PAL which contains 4 product terms in each output equation. So 4 product terms means automatically the number of product terms increases. No, here how many product terms we are taking? 3 3 3 3. So 12 product terms we are taking. For example, if each gate contains 4 product terms means totally we are going to consider 16. So if the number of terms increases, automatically what happens? The size of the chip is also increases, no? But here we are connecting W as the input, so due to that we can reduce 4 number of AND gates across this point. That is the advantage by considering that one as a input. Okay. Is there any doubts in this? I will give you the homework also. Okay, this is how we are going to design the PAL. So next we are going to discuss about the last topics in this memories, which are CPLD and also FPGA. So we are discussing up to now programmable logic devices. Next, programmable logic devices means those are all nothing but the SPLDs. What is meant by SPLD? Simple programmable logic device. Simple programmable logic device means, for example, if you want to implement any one of a simple combinational circuits or any circuits, we are going to implement those by using simple programmable logic devices. That is either by using PLA or by using PAL or by using PROM. Now for example, if you want to implement any one of the application, that application may contains some 3 AND gates, sorry, 3 adders, 4 subtractors, some 2 multipliers, then what happens? The complexity of the circuit is increases. So across those cases, what we are going to do is we need to consider 2 types of devices which are called as CPLD and another one is called as FPGA. CPLD means complex programmable logic device and FPGA means field programmable logic array. So when we are going to consider this CPLD, main block diagram of this CPLD is this one, which contains PLDs. That is, this PLD may be a ROM or PLA or PAL. So for example, if you want to implement parallel adder, generally what we are going to do, if you want to implement a parallel adder means we need to connect 4 full adders, but by using the PLD we can implement one full adder only. Then what we are going to do, this PLD acts as one full adder, this PLD acts as another full adder, this PLD acts as a third full adder, this one fourth full adder. After that, after implementing individual PLDs, then what we are going to do is, by using the global interconnection matrix, we are connecting these 4 PLDs. Then after doing this, what happens? This full adders all are connecting, and this one acts as a parallel adder. And here we are going to use input output devices and internal connections. Like this we are implementing the CPLD. Just nothing but we are taking the individual PLDs, and by connecting all these individual PLDs we are going to get the CPLD. That's why we are calling this CPLD as a complex programmable logic device. Complex programmable logic device. Okay, so next, when we are going to consider the next type of uh, complex PLDs, is one is the CPLD and second one is the FPGA. So this FPGA is field programmable gate array. So field programmable gate array means, what is the meaning of this one is, this FPGA kit is already available. Just what we are going to do is, whatever the circuit which we are having, or whatever the connections we are going to do, always we are going to do this by using a software. That is, here two types of softwares mainly we are going to use. One is called as Verilog, and another one is called as a VHDL. Another one is called as VHDL. So these softwares we are going to use for implementing this FPGA. So why we are going to use these softwares is, if you are writing any program in the software, just what we are going to do is, you just dump this software in the FPGA kit. So when you dump this software in the FPGA kit, that FPGA kit acts as that application. That is, if you are writing any program for the multiplier circuit, then what happens is, we are going to write the program in the Verilog code, or it is in the VHDL code. So after writing that in the Verilog or the VHDL code, then what we are going to do is, for the computer you are just connecting that to FPGA kit, and if you dump this program into this FPGA kit, then what happens is, it takes the internal connections automatically based on how we are going to write the program. So with respect to that, what happens is, we are, that kit acts like a corresponding application. So that's why we are calling this one as a field programmable gate array. So mainly when we are considering the structure of this field programmable gate array, this field programmable gate array mainly contains three parts. One is called as the programmable logic structure, second one is called as the programmable routine structure, and third one is called as the programmable input outputs. By seeing this, you can already understand this one. What is meant by programmable logic structure? So this programmable logic structure means, whatever the application if you want to implement, you just write the program or the logic across this programmable logic structure block. After that, programmable routine structure means, this programmable logic structure is mainly considered in the CLB block. This CLB is called as a configurable logic block. After that, if you are writing this in the configurable logic blocks, next what we are having, you have to do the internal connections. So if you want to do the connections here from one CLB to another CLB, then what we are going to do is, you have to use this programmable routine structures. Mainly these programmable routine structures are three types. One is vertical and horizontal routine channels, and third one is the horizontal connection box, that is the connections between the horizontal and vertical lines, that is called as the switch box, and second one is the connection between the one CLB to the another CLB. So if we are having connections between one CLB to the another CLB, either you can use our horizontal connection box, or you can use this vertical connection box. So that is the second type of connections we can do. And third type is for the connections between the horizontal and vertical lines, and this connection is called as the switch box. So these are the three types of connections which we are having. So one is called as vertical and horizontal routine channels, and second one is from one CLB to the another CLB. These are all called as horizontal connection boxes and vertical connection boxes. And third one is the switch box. So this switch box is connecting horizontal lines with the vertical lines, or horizontal channels with the vertical channels. And third one is third type of structure we are having in this FPGA. Main structure we are having is programmable input output. So when we are taking this programmable routine structures, this programmable routine structure gives the internal connections only. That is, if you are having any in logic, based on this logic, if you are going to do any internal connections, you just use this programmable routine structure. But if you want to give any external inputs, or if you want to see any external output, then what we are going to do is you just use this programmable input output. So these programmable input output devices are like this. So across the external part we are going to consider this programmable inouts. So across these points we are going to give the connections for the CLBs. What is meant by a CLB? Configurable logic blocks. So mainly whatever the program which we are having, these programs are internally connected for the CLBs, and also the input outputs are connected by using the programmable input output. And internal connections, whatever the connections which we are having internally, those are all connected by using this horizontal connection boxes, vertical connection boxes, and also with the switch boxes. Okay, so this is how we are going to do the uh, connections in the CPLD, and also this is FPGA. Sorry, this is CPLD and this one is the FPGA connections. This is about the second part of the fifth unit. From Monday onwards, I am going to start the first part of the fifth unit, which is semiconductor devices. That is logic families we are going to do. That is by using the transistors and also by using the diodes, how we are going to implement NAND NOR logics or AND or inverter logics. Okay. If you are having any doubts, you just ask me. I will send you the this PPT, and also I will send you some of the problems related to this PLA, PAL, and also the ROM. You just practice those problems, and if you are having any doubts, message me. I will send you the answers. Okay.
Okay.
Any doubts? No one is having doubts. While these many less people are joined today, 33 people only. Bashwant,
Ma'am,
వీకెండ్ మేడం.
weekend
అవును
అవునా?
వీకెండ్ అందులో
ఇంట్లో
సెకండ్
ఉన్నా
సాటర్డే
వీకెండే, మనకి కాలేజ్కి వచ్చినా వీకెండే. ఇంట్లో ఉండి కనెక్ట్ అవ్వి వినడానికి ఏంటి ప్రాబ్లము?
వీకెండ్
ఇంక ఇదే ఆన్సర్ చెప్పండి. ఇదంతా రికార్డ్ చేస్తున్నానులే, డైరెక్ట్ సెర్చ్ చూపిస్తా. తప్పకుండా అంట. దేనికి భయాలు లేవు అసలు.